All right, in this video, we're going over a topic from section 1.1, which is on determining whether linear equations in one variable have 0, 1, or infinitely many solutions. Okay, so let's go ahead and take a look at just the examples. We'll go through a few of them to try to find each of the cases. So let's start with or part A. -3 times 2x minus 5 equals -9 minus 6x plus 15. Okay, so we're just going to try to solve this equation here for x. And so if we distribute, we get -6x plus 15 equals -9 minus 6x plus 15. Usually what we'll do is combine like terms after this step. So there's a -9 and a positive 15. So we have -6x plus 15 equals -6x plus 6. And so from here, you might already know what the answer is. So what we would normally do, though, if we had a solution, is we would try to get all of the variable terms on one side. So we would add 6x to get rid of the minus 6x, and we would add 6x on the other side as well. But it turns out that there's a minus 6x on both sides, so adding 6x gets rid of all of the x's. And so we have 0x, or plus 15, equals 0x plus 6. Or 0 times x is just 0, so we have 15 equals 6. Okay, so we've tried to solve for x. The x's just all canceled out in the process. And we got a statement that says the number 15 is equal to the number 6. Right, and so that's just not true. This is a false statement. We could say this is nonsense. 15 is not equal to 6. And what this implies is that there is no solution. We were talking about solution sets in a previous video when we were talking about interval notation. So in this case, the solution set would be the empty set. There is no solution. Okay, so we've actually looked at, in the previous video, we looked at solving equations. When there is a solution, you just get, that variable that you're solving for equal to some number. When there's no solution, the variables actually end up canceling each other out, and we end up with a false statement. That false statement implies that there is no solution. We also talked about in the previous video what it meant for something to be a solution, and we said you can take that number, plug in back into the original equation, and get a true statement. So what this here says is that there is no number that you could plug into the original equation to get a true statement. Okay, and you could actually see it here in this step because well, you can see that they both have a -6x. But then one of the sides of the equation adds 15, the other side adds only 6, and the equation is claiming that the two sides are equal, but you could see that, the two sides will never be equal. So, there is no solution. Okay. Now, I always tell my students that you want to, kind of simplify this as much as you can so you can clearly see that this is a false statement, and, that way you can get full credit on an quiz or exam. Okay, so that was number 1, or part A. Let's go ahead and take a look at part B. 10 minus 4x plus minus 3. Ooh, this is a good one. Equals -2 plus 3 times x minus 1. This is a good problem for many reasons. But one of the reasons is a lot of times students want to combine this -2 and that +3. And we don't want to do that because that would be an addition problem. And what we're doing here is we need to simplify this. We need to use the order of operations. Please excuse my dear Aunt Sally. And so the multiplication that the 3 is going to do to this x minus 1, the multiplication should come before any addition, right? The addition is right here. It comes after multiplication. So we'll distribute the 3 rather than add it to the -2. And then Also, another mistake that students commonly make is this 10 with a minus sign or just the 10 will often get distributed into these parentheses. That is also incorrect. You can think of this minus next to the parentheses as a minus 1, and we will distribute that negative 1 into the set of parentheses. Okay. Because if we're subtracting 4x minus 3, then that means you're subtracting 4x and you're subtracting a negative 3, which is really just like adding 3. Okay, so we end up with 10 minus 4x plus 3 equals negative 2 plus 3x minus 3. Now let's combine like terms. Negative 4x, 10 plus 3 is 13. 3x minus 2 and minus 3 give us a minus 5. And then we can move the terms around. Let's go ahead and let's subtract 3x from the right side. Do it to the left side as well. And at the same time, let's go ahead and subtract 13 from the left side, and we'll do it from the right side as well. So negative 4x minus 3x is negative 7x equals negative 18. Then we can divide by negative 7. So we have x equals negative 18. And there's two negatives, so let's go ahead and just cancel out the negatives. 18 over 7. That is our solution. It looks like there is one solution there, and we found it. It's 18 over 7. Okay, so let's check the answer just there, just real quick. Yeah, it is 18 over 7. Just to make sure I didn't make a mistake. Make a little slip up. So there we have examples of no solution and one solution. Let's go ahead and take a look at part C. Part C will be the last one for this video. Let's see here. Part C, that's 2x plus 4 times the quantity x minus 1 equals 6x minus 4. Now, part C, let's see, we can start by distributing the 4. And so we have 2x plus 4x minus 4 equals 6x minus 4. 2x plus 4x is 6x minus 4, 6x minus 4. At this point, you can see both sides are identical. And so you can see then that if we plug in any number for x, any x value that we plug in at this point, if you plug it in on the left and you plug it in on the right, you're going to get a true statement. So that means that any number, any real number, is a solution here. And so again, I would say, okay, well, subtract 6x on both sides, and we get negative 4, a constant number. The x's completely go away, but what's different from the 15 equals 6 from earlier is that now we get something that is true. Negative 4 equals negative 4. That is just an obviously true statement. And so what that implies is that there are infinitely many solutions. If we want to be a little bit more technical, all real numbers are solutions, which can be written with this little fancy R. So infinitely many solutions, yeah, that's good enough. But there are inequalities that could have infinitely many solutions, like from 0 to, let's say, or actually all numbers from 0 to 5. That's infinitely many solutions because there's tons of decimals, but that's not all real numbers, right? So in this case, we could go further than infinitely many solutions, and we can actually say that all real numbers are solutions. Okay. All right, and there we've demonstrated the 3 different cases that exist for solving a first or a linear equation in one variable. You can do parts D and E on your own. The answers are right here, 5D and 5E. try them on your own and see if you can get the correct answer. Yeah, and we'll stop the video there.